Hello, dear guys.
Hello.
Can you hear me and see me?
Yes.
Yeah.
Excellent. We are coming closer and closer to the end of this very difficult for us semester. I have very important announcement for today, and which is about coming today quiz, which will be quiz number 5, so-called, as I mentioned this on Wiley Plus, name that as quiz number 5 in class. So you will take this quiz again using Wiley Plus. It will be at the end of our class. It will start at 12:45. So practically up to 12:45, I can solve more problems. And after that, you need to switch to Wiley Plus to do that problems, to take that quiz. And the maximum, you will have 30 minutes for that particular online through Wiley Plus quiz. Is it clear? Do you have any questions?
No.
No, it's clear.
You already did that before, so it will be the same thing again at 12:45, because I see some new people are arriving. I see names here on the side. This is why, again, at 12:45, you have to start your quiz number 5, and you will take it using Wiley Plus site. Do you want to ask me about anything, what confused you maybe? Because I will be more than happy to help. If not, I will continue. Today will be our practically last time when we work with complex numbers, and tomorrow I am planning to cover different material from different chapter.
I have a question.
Okay.
This is kind of regarding like solving problems and the homework, because I have a question about number 26, and it's I guess it's the same one.
Okay, 1 second, please. Let me grab that textbook. Are you talking about problem number 26 from the textbook, right?
Yes.
Okay.
Thank you.
You're welcome. If the roots of the equation x squared plus 2bx plus c equals to 0 are the complex numbers, and they are coming in the form of p plus or minus I times q, find expression for p in q in terms of b and c. Let's solve that problem. Again, this is on page 392. This is from section 9.6, and this is problem number 26. Let me read it one more time. I will do that a little bit slower right now, and probably a little bit more, let's say, not 1 second, please. Let me grab my alarm. Stop. Okay, and a little bit louder. If the root of the equation, and let me write that equation, 2bx in the middle, x squared plus 2bx plus c equals to 0. As you can see, this is a quadratic equation. Our complex numbers, okay, x1 and x2 are complex numbers. X1 and X2 both belong to set C. C is a set of all complex numbers. And they are coming in form of, I can even write this separately, like P plus I times Q. X2 is P minus I times Q. Find expressions for P and Q. Find expressions for P and Q in terms of B and C. This is how I wrote this problem on the paper, using just math symbols. As we understand here, B and C are parameters. They are parameters, which means there are given fixed numbers. They are given fixed numbers. So this is why in our answers, we need to have, let's say, P equals to something which will have B and C in it, and same thing for Q. Okay. Let me go back to our past when I was reviewing the few different methods to solve quadratic equations. And we can use here absolutely different methods to solve this particular problem. But there is one method which is much more mathematically elegant than all others. Because if you like, you can even apply, let's say, quadratic formula to find your x1 and x2, and after that, connect them with B and C, because your equation has a form of x squared plus 2bx plus c equals to 0, which means a coefficient is 1. Middle coefficient, which we usually call B, is equal to 2b, and the last one is c. So you can use quadratic formula, but there is again a better way to do that. Now look what we have. I released to you the theorem of Viet, and let me actually remind you that theorem for the regular standard form of quadratic equation. I just wrote it down in the form of ax squared plus bx plus c equals to 0. If this is a, let's say, a is a first coefficient, b is the middle coefficient, and c is the last or numerical term or a constant term of that. It doesn't matter how we call that. C has 3 different names. The theorem of Viet states that if x1 and x2 are solutions of that equation, and for us, it doesn't matter if they are real or complex, because theorem Viet is applicable to all cases, then x1 plus x2 equals minus b over a, and x1 times x2 equals c over a. I am going to box that result of theorem of Viet. This is the theorem of Viet. For any equation, we have this. So this is why we are going to use theorem of, did you copy that, what I wrote in this box?
Yes.
Yes.
Excellent. Let's do that. So what do we have in our problem? It has specific form x squared plus 2bx plus c. So which means x1 plus x2 will be equal to negative sign, fraction. What do we have on the top? We have 2b because it is the value of the middle coefficient, divided by 1 because it is a value for our particular problem. Then it means that x1 plus x2 equals negative 2b. Is it clear? I used the first line in that box, which represented the theorem of Viet. Do you understand where it is coming from?
Yes.
Excellent. Now, let's see what we can get from this actually statement. X1 is P plus IQ, X2 is P minus IQ. So, which means X1 plus X2 will be equal to P plus IQ plus P minus IQ. Can we cancel anything?
Yes.
Can you see that these two numbers, for us, they are numbers, P plus IQ and P minus IQ, they are complex conjugates. They have absolutely same real part and they have opposite imaginary parts. Can we cancel imaginary parts?
Yes.
Yes.
Are we left with 2P?
Yes.
So, and look what we have. From one hand, our x1 plus x2 equals to negative 2b, and I'm going to box this result. From the other hand, x1 plus x2 equals to 2p. Can I use transitive property? Because in both lines, we have x1 plus x2. From one hand, it is equal to negative 2b. From the other hand, it is equal to 2p. Can I this time state that negative 2b equals to 2p?
Yeah.
Can we divide both sides by 2?
Yeah.
Yes.
And what do we get out of that? Can you help me, please? Were we asked to find P and Q values in terms of B and C?
P equals to -1.
Negative B. Where did you get -1? Because we just divided both sides by 2. Is it true that P equal to negative B?
Yeah.
Yes.
That's it. Did we find already one value?
Yes.
Yeah.
And I use just the first statement in theorem of Viet. I will be using now the second statement. So let's say this is first part. Now this is the second part. x1 times x2 equals the third parameter or coefficient in a quadratic equation, which is in general standard form, is c. In our case, it is also c, equals to what? Is it equals to a equals to 1?
Yes.
Yeah.
Can I write this in that form? x1 times x2 equals c over 1. Is it c?
Yeah.
Mm-hmm.
So wrote it down. This is from one hand. From the other hand, x1 times x2, is it equal to parenthesis p plus I times q times p minus I times q?
Yes.
Is it a plus b times a minus b form?
Yes.
You can even use the shortcut because I already told you about that in the set of complex numbers, actually, if you multiply two complex conjugates, the answer will be p squared plus q squared. If we do not have this I, it is p plus q times p minus q. In this case, it will be p squared minus q squared. But because we have this I, and you know I squared is -1, then using the shortcut as a formula, because I already showed this to you the last time, we are getting that x1 times x2 from one hand is p squared plus q squared. From the other hand, it is c, and I box that also. So can I say that now, because I have these two last lines, p squared plus q squared equals to c?
Yes.
Yeah.
This is what I wrote down. But did we know already value of p?
It's negative.
Is it negative b?
Yes.
Yes.
Plug it in. So negative b squared plus q squared equals to c. Negative b squared is b squared plus q squared equals to c. And I'm getting quite simple equation with q as an unknown, because b and c are parameters given in this problem. So we need to treat them as we would treat regular numbers. I'm going to move b squared to the other side. So I'm getting q squared equals c minus b squared. But I'm not interested in q squared. I need to find q value. So excellent. Q equals, because I'm going to take square root from both sides, but I need to find all possible values. This is why I cannot ignore that I'm working with square root. So it will be q equals plus or minus square root of c minus b squared. I found the other value, which was q, in terms of b and c as it was requested. I completely solved this problem. And I agree that probably for students, it is a little bit challenging as a problem. This is why I was more than happy when you asked me about this problem. And I hope I was able to explain all details. And this theorem of Viet, which you can see on the left side in the box, is an awesome theorem which can help us a lot in many occasions when we work with quadratic equations. And actually, unfortunately, it's not in the textbook, but I told about this theorem in that chapter where we were going over quadratic equations, because quadratic functions, equations, if you remember, I even showed you 3 quadratic formulas. I showed you theorem of Viet. I told you about completing the square method. I released all the required information. Just check your notes for that chapter. Are you satisfied, guys?
Yes. Thank you so much.
You're
Yeah.
welcome. But I would like to talk about another very interesting fact, because I really like to ask you to look at one of problems on page 393. By the way, can I remove this paper because I need to grab another one for another problem?
Yes, that's fine.
Okay. So, and this is on page 393. And let's say this is a very simple problem like number 33. Problem number 33 or 34. Okay, let's say number 34, because 33 will have the answer, and you can look at this. 34 is a cousin of that. So what should I do here? Okay, I'm going to read. In problems 32 to 35, find polar and Cartesian forms for all 3 cube roots of the complex number. This is a very important sentence because if you look again at this sentence, it tells us to find all three cube roots values, three values of the cube root from 8. Look what I'm going to do. I will name this number like z is equal to 8.
Wait, which problem are we doing, Professor?
Can you repeat, please?
Which problem are we doing again?
This is problem 34. Yeah, it is my fault. I did not write on the paper. Problem number 34. And all others should be solved in similar way. First of all, I would like to tell you that there is a big difference between, let's say, set of real numbers and complex numbers. If you need to find any root with index n in the set of complex numbers, you should get n different values for the nth root of any complex number. So if your index is 3, in other words, it is a cube root, you need to get 3 different values. And let's start. First thing, write it in algebraic form because it is a real number, but can I write this in that form?
Yes.
Excellent. This is so-called algebraic form. Right now, I really like to ask you to think about the location of that number. Is it a positive 8? Is it actually a positive real number? If you have a coordinate plane with a horizontal axis, vertical axis, which point will be actually showing the location of that number? Is it on horizontal axis on the right side from the center origin, on the distance of 8 units from the origin, right?
Yes.
Does it mean that actually, again, you can use this like using, let's say, conversion into polar coordinates, because for this actually number, x is equal to 8, y is equal to 0. So if you need to find the r modulus of that, it is actually modulus or absolute value of that number. So practically, if you need to find the absolute value of any complex number, you need to find r, because that r is your absolute value of any complex numbers. I will write this on the top. R equals to the absolute value of z, and it equals square root of x squared plus y squared. Again, I don't know why the book is not showing all these details. So it is the absolute value of that complex number z. R is equal to 8 squared, which is 64, plus 0 squared. So it is square root of 64. So you have R equal to 8. Besides that, I need to find theta because I am going to convert this into a polar form or exponential form. So I need to find tangent of theta. Tangent of theta equals y over x, which is 0 over 8, which is 0. And I know that tangent is equal to 0. And z's location is on horizontal axis. So which means solving this easy trigonometric equation, I am getting arc tangent of 0 here. So which means it is actually 0 radians. So which means my number z in the polar form will look as 8 times e times e, 0 times I, or I times 0, up to you. I converted this into polar form. I had algebraic form, now it is a polar form. Now look what I'm going to do. I'm going to write the formula. Here also it is in the box. When we multiply two complex numbers, we multiply r's and we add angles. We multiply r's and we add angles. This is why it is much easier to perform this multiplication in the polar form or trigonometric form. In the polar form, you can write that it will be r1 times r2 e to the theta 1 plus theta 2 times I, but in trigonometric form, it is easier. And you know what, in time, we can convert polar form into trigonometric into polar without any problems. If you need to divide two complex numbers, you need, in this form, same form, you need to divide their r's and you need to subtract exponents. If you need to take nth root of any number in the complex form, you are doing this theta plus 2 pi k, 2 pi k over n plus I sine theta plus 2 pi k over n, where your k runs from 0 up to n minus 1. Please carefully write that bottom formula.
Can you move
Can
the
you move
paper
the
over?
paper?
Thank you.
So this why it shows that if you need to find all n roots, you will get, playing with k, you can get n values because you are starting not with 1, you are starting with 0 and up to n minus 1. In this case, we are going to find cube root out of our z, which is given in the form of 8 times e to that power. So, which means it will be cube root of 8 times cube root of e to the 0i, which in trigonometric form looks as cube root of, for e to the 0i, it is cosine, I'm using Euler's formula, of 0 plus I sine of 0. Cube root of 8 is 2. Now I am applying that last formula in the box, and look what I'm getting right now. It will be parenthesis cosine of 0 plus 2 pi k over 3 plus I sine 0 plus 2 pi k over 3, where my k starts with 0 and runs up to n minus 1, which means 3 minus 1, which is 2. These are k values. K values. 0 plus 2 pi k is just 2 pi k. This y cosine 2 pi k over 3 plus I sine 2 pi k over 3. And now I'm going to play with k values and I will get all 3 values. Please write it down. So k is equal to 0, then z, okay, let's call it z1. will be 2 times, again, k is 0, which means 2 pi times 0 is 0, divided by 3 will be 0. It will be cosine of 0 plus I sine of 0, which means we need to know values of cosine of 0 and sine of 0. From trigonometry, it will be 2. Cosine of 0 is 1. Sine of 0 is 0. So I times 0 is 0, plus 1, it is 1. So it is your first value, 2. And this is your first cube root of 8. Second, k is equal to 1. Then z2 equals 2. 1, which means 2 pi over 3 cosine of 2 pi over 3 plus I sine of 2 pi over 3. I'm a little bit in hurry, so I will leave it to you to finish this value. You will get another one. And k is equal to 2. Then z3 will be equal to 2 cosine. You are plugging into that formula, k is equal to 2. It will be 2 pi times 2, which is 4 pi over 3, plus I. It is z2 and z3. The third value is not finished. This y, I definitely will finish. I wanted to finish everything today, but I really ask you to finish this problem. So, because again, this is what you are getting, and you will get all 3 values. You can see I put 3 dots under Z2 line and Z3 line because they are unfinished. We need to simplify that. Okay, I will definitely at the beginning of tomorrow's lecture will say a few words about this problem for sure. Did you understand where we are getting that all 3 values? This one answer will be, for that cube root, will be a real number. Cube root of 8 is a real number equal to 2. And 2 other will be actually your complex answers. I'm not going to check right now attendance because anyway, you have to take that quiz. So I will have the access who took that quiz. And I will treat this like our attendance for today. I will let you go right now. I will be staying here on that actually screen up to the end of class. So if you are done earlier, you come back and talk to me. Good luck. And I will let you right now go to Wiley Plus site to take your quiz. Is it clear to everyone?
Yes.
Yes.
Yeah.
Good luck. And again, I am here up to the end of today's lecture. I will be waiting. Maybe someone can come back to me. Okay?
Okay.
Okay.
Please go to Wiley Plus to take that quiz. Please do that. It is quite urgent. Chantal, are you still here?
Yeah, I'm still here.
But why you are not taking the quiz on Wiley Plus?
I am. I'm on it right now.
You are on other device as well?
Yes.
Excellent. No questions. I will not bother you.
Okay.
Gabriel, what about you? Aline,
Oh, yeah.
are you taking that quiz?
Yes.
Good.
I'm also taking.
Excellent, guys. I just saw, I see your names here on the screen. That's why I asked you. Okay. Good luck.
Professor,
Yes.
tomorrow can you explain problem number 20 and number 24?
You mean from your homework?
No, from the textbook in chapter 9.6.
9.6, okay. And who is talking to me, Lynn?
Yeah,
Okay. So 20.
and 24.
Yes, I can solve tomorrow. Are you asking about tomorrow's class?
Yeah,
Let me write it down. Just 1 second, please, so I will not forget. Okay. From Lynn. Okay. Page 392. Number, did you say 20
yeah,
and
24.
24 and
That's it.
number 24 for tomorrow for 5/5/20, right? Yes,
Thank you.
this is what I wrote down. Is it correct?
Yes,
Excellent. Definitely.
thank you.
You're welcome. How was your quiz for you?
I'm done.
Excellent. I think it was quite easy if you know the material.
Yeah.
Yeah. Okay, so I will see you tomorrow.
Okay, thank you.
Have a nice day.
You too.
Thank you very much.